climate change, dwindling natural resources, and warfare have all culminated in a real challenge to the future of existence. Global food security, equitable provision of health and social security, provision of education, and enforcement of law and order have all been challenged in ways that have been anticipated at the beginning of the new millennium. South Asian countries have been grappling with economic shutdown in the post-COVID era, but Sri Lanka, in particular, with its over-reliance on traditional exports, tourism, and constant geopolitical battles, has had its livelihood being affected the most. In this pursuit, we should analyze the strategic role of the academia of the country to collectively come together and facilitate the transfer of knowledge, skills, and solutions using science, technology, and innovation to achieve a profound impact on reviving the trajectory of the nation's economy to achieve sustainable economic growth coupled with an environment of justice and enhanced security for all. Achieving sustainability through research and innovation. A very good afternoon to you all, distinguished chairpersonnel and the panelists, Dean of the Faculty of Engineering, Captain Engineer S.U. Dampage, heads of the departments, lecturers, ladies and gentlemen. Welcome to the plenary session of the Faculty of Engineering of the 15th episode of the KDU IRC, the International Research Conference 2022. Chairing the session today, we have Professor Kumari Fernando, Department of Civil Engineering KDU, and Engineer Dr. Kamal Laksiri, the President of the Institute of Engineers Sri Lanka. Joining us today in the panel, we have eminent Sri Lankan scholars across the hemispheres, Professor Jayantha Obeysekara, Director and Research Professor, Sea Level Solutions Center, Florida International University, Florida. Professor Chandima Gomes, Distinguished Professor and the Chair of EPPEI HVAC, School of Electrical and Information Engineering, Braamfontein West Campus, Johannesburg. Professor Priyan Mendes, the Professor of Infrastructure Engineering from the Department of Infrastructure Engineering and Director of the Center of Advanced Manufacturing and Prefabricated Modular Housing of University of Melbourne, Australia. And finally, Engineer Chandana N Dalugoda, the Managing Partner and Lead Consultant of Chandana Dalugoda Consultants and Director of Green Buildings Council, Sri Lanka. Sir, Madam, may I now have the honor of inviting you to take off your seats at the head table. Ladies and gentlemen, may I now have the honor of introducing to you the chairperson of the session today. We have Engineer Dr. Kamal Laksiri, who's a chartered engineer and the project director of the Broadband Hydropower Project in Ceylon Electricity Board, Sri Lanka, with over 20 years of experience in consultancy and construction industry, specializing in hydropower engineering, and is mainly concerned with the optimum use of water in the energy sector. Engineer Laksiri graduated with a BSc in Civil Engineering from University of Moratuwa. Then, he completed his postgraduate degree of Masters in Hydropower from Norwegian University of Science and Technology, and a Doctor in Philosophy in Dam Engineering from Saga University, Japan. Engineer Laksiri worked as an engineer in the Ceylon Electricity Board and got the opportunity to engage and work in all types of hydropower projects. He worked as a reservoir engineer at Samanalavawa Hydroelectric Project as the chief engineer of Kukuleganga Hydropower Project. He was a project consultant in the international major construction project with leading international contractors and consultants. Further, Dr. Laksiri served as the chairman of the Sri Lanka Association of the Institution of Civil Engineers UK and is a past president of the Association of Consulting Engineers Sri Lanka and serves as an executive committee member of the FIDIC Asia Pacific Group representing Sri Lanka. He served as a member of Strategic Council Member International Water Association and as the Vice President of Sri Lanka National Committee on Large Dams and President-elect of the Institute of Engineers Sri Lanka in 2022. Engineer Dr. Laksiri has got elected as a Governor Region 10 of the American Society of Civil Engineers, which is ASCE, United States for the term 2021 to 2024, becoming the first Sri Lankan to be the governor. Next, we have Professor Kumari Fernando. Professor Kumari Fernando is attached to the Department of Civil Engineering, Faculty of Engineering in General Sir John Kotelawala Defence University. She graduated with a BSc in Civil Engineering with first-class honours from University of Moratuwa and completed her Masters in Engineering in Environmental Water Resources Engineering and Management and Doctor of Philosophy in Civil Engineering from the same university. She joined KDU in 2001 and has served a member of many appointments such as Head of the Department of Civil Engineering, the Dean Faculty of Engineering, and also she became a professor in Civil Engineering from KDU in 2020. Professor Kumari Fernando became the best civil engineering student in transportation geotechnical engineering for the term 1988-89 at the University of Moratuwa. She received IESL IWMI Award for the best technical paper on water resources development and future challenges, and also the Staff and Educational Development Association UK Award. In 2011, she received a Merit Award from the National Research Council, the NRC, for scientific publication and holds professional affiliations in Sri Lanka Association for Improving Higher Education Effectiveness, Sri Lanka Association for the Advancement of Science, and the Institution of Engineers Sri Lanka. Professor Kumari Fernando is an outstanding researcher and has published over 30 research articles in reputed journals as well as local and international conferences in the areas of hydrology, extreme rainfall estimation, and outcome-based education. Sir, Madam, over to you.
Good afternoon to all of you, and good morning and good evening to the resource persons joining from South Africa, USA, and Australia. Let me welcome you all to the plenary session titled Achieving Sustainability Through Research and Innovation. So in this session today, we have 4 interesting papers lined up. And all the 3 presenters are joining online and 1 presenter attending from here in person. I hope Now, these presenters, as I said, Australia, USA, and South Africa, the three presenters. So each presenter will get 25 minutes for their presentations. And at the end of all the presentation, we will take up all the questions you have. In the Q&A session, actually, you all can directly raise the questions. And those who are joining online can put up their questions in the chat box, and we will attend to it. And also we will indicate you the time. Our timekeeper will indicate when you come to the end of the allocated time, and I kindly request you all to stick to the time because we have a tight schedule with 4 presentations. So with that, let me get into the presentations, and the co-chair, Dr. Kumari Fernando, will introduce the speakers. Thank you.
Thank you, Dr. Laksiri. So today we are here to listen to the first talk on climate change, rethinking the practice of engineering. So, are hydroclimatic extremes stationary or non-stationary? This is a debating question in this dynamic world. As engineers, we are all involved with design work, and maybe it is design of hydraulic structures. In that case, can we use stationarity in estimating the risk? Let us see how we can embark on the discussion of changing the traditional practices of engineering in the context of climate change. Our speaker, Professor Jayantha Obeysekara, has over 30 years of experience in water management, hydrologic modeling, climate change, and sea level rise. Professor Obeysekara graduated with BSc Honours in Civil Engineering from the University of Sri Lanka and earned a Master of Engineering from the University of Roorkee, India. He obtained the Doctor of Philosophy, specializing in water resources from Colorado State University. He is a research professor and director of the Sea Level Solutions Center at Florida International University. He held many positions, starting from assistant professor in different universities, Colorado State University, George Washington University, Florida Atlantic University, and as associate professor at the University of South Florida. Further, he is a chief modeler at the South Florida Water Management District, a regional government agency in South Florida. He served as a member of the Federal Advisory Committee, which directed the development of the most recent National Climate Assessment. Professor Obeysekara has published over 200 research articles, including in numerous peer-reviewed journals and conferences. He was also a co-author of the Sea Level Rise Projections report published by NOAA for the National Climate Assessment. He also served as a member of the Coastal Assessment Regional Scenario Working Group associated with the Department of Defense in the USA. He was a recipient of the prestigious 2015 Norman Medal of the American Society of Civil Engineers for the technical paper Revisiting the Concept of Return Period and Risk for Non-Stationary Hydrologic Extreme Events. With this introduction, ladies and gentlemen, please welcome Professor Jayantha Obeysekara. Professor Obeysekara.
So just to get started, the video you're seeing on the upper left is some flooding in Miami Beach that, related to what I'm going to talk about. And I just want to let you know the entire state of Florida is experiencing a major hurricane going through not too far from where I am right now. And I'm hoping the power will not be out, during my talk. We have had major storm going through here. So I just want to I want to thank Professor Kumari Fernando for inviting me. And it's always a pleasure to share my research experience. And I picked this sort of a catchy title to send the message to young engineering professionals, this idea of climate change and how we need to change the practice of engineering. And I hope the chairpersons will let me know if I'm running, beyond my time allocated. Just to bring us back to the process of it. Obviously, I'm not going to spend too much time on this. This greenhouse gas effect, you see on the lower left-hand corner, the carbon dioxide measurements in Hawaii, basically increasing continuously. And this warming is actually a good thing. Too much of a good thing. And otherwise, we'll not be able to live on this planet. But more importantly, the question is, what effect it has on the environment. So my key messages from this talk are climate change is a threat multiplier, and we need a new paradigm in practicing practice of engineering. And I'm going to kind of share some of my ideas and experiences and research outcomes. This message called stationarity is dead, and you will know what stationarity is after my talk, hopefully. Whether we can continue to practice engineering, building of infrastructure, the same way we have learned in school or doing in practice. Basically, the climate change itself undermines the assumptions that we have been using historically for management of water supply, demands, and risk. Now, my focus is primarily on water resources, but also maybe I'll touch on transportation, but it can apply to any many areas of civil engineering in general. So the other message is we need to come up with a new paradigm to plan projects under future conditions, which is what we are not doing now for most part. And we need to adapt the engineering curriculum to this concept that I call resilient sustainability. The sustainability we've been talking about for decades, but now we have to be resilient in doing that. And you will see why, because of this concept of non-stationality. And the other message I'm going to convey in this short time is, how do we deal with this deep uncertainty? We know how to deal with uncertainty, but we have situations of deep uncertainty. And I'm going to introduce this concept of dynamic adaptation. So we already see signs of climate change. All these arrows going up are the ones that are increasing. There's data behind every one of these. And the arrows going down also indicate climate change. So these are all consistent with what is being predicted, in climate change science. And you see this a little insert on the left-hand side. The NASA produces this sort of a metrics that indicates where we are in terms of carbon dioxide, global temperature, sea level, and others. So this is the background is, and we have at global scale, we have already some indications about, maybe more than a degree Celsius in warming on the planet, since the pre-industrial era, as you can see from the atmospheric warming, and then the sea level, rising sea levels, and it seems to be accelerating currently at the rate of 3.3, 3.4 millimeters per year, which for low-lying areas that could be significant. So climate change, basically alters the hydrologic cycle. Some say it is going to be on steroids because of the increased energy that is on the planet. Much of the climate change, the energy from climate change, the heat is absorbed by the ocean, about 90%. So that's a big storage of heat, and that could result in changes in climate globally. So our primary variables of interest in our planning of design is the temperature, precipitation, evapotranspiration, and sea levels. And as you all probably agree with me, it will have implications for ecosystems, human health, water management, energy, agriculture, economics, and many more, including other sectors like transportation. So I've been looking at Sri Lankan data for some time on and off. I've been away from Sri Lanka for probably about 40, 50 years, but still I've been in touch with Sri Lanka on many occasions. So this is the work we did with Narendra Kumar. He did work with my help on basically looking at trends. And you see the map of Sri Lanka, about 20 stations. All these arrows or red diamonds indicate, triangles indicate the warming trend. These are all statistically significant. And you have, in general, in the middle figure, the warming rate, about 0.15, 0.2 degrees per decade. And we probably all see that. And this right-hand figure showing, the season, how seasonally it has been warming continuously for each decade. You can see the circles becoming bigger and bigger. That means in every month, we are becoming warmer and warmer. And I'm sure many of you who live in these areas, like Colombo, are feeling it. So another aspect is, what will happen to the sea level? We are surrounded by sea level all around. It's a wonderful tool from NASA that you can go to, and globally you can look at the sea level rise rate. And I kind of pulled up the point closest to Sri Lanka in Maldives, and you can see by 2100 you'll have a 1 meter or more, depending on the greenhouse gas scenario or emission scenarios you see on the upper right-hand corner. So warming is not going to stop, and the sea level is going to rise continuously. And that's something we have to be cognizant on when we are planning or designing projects all along the coastline. And I'll show you some examples of what's happening or what could happen. This particular site also tells you for different scenarios when you can expect, let's say, a half a meter or 1 meter of sea level rise. And obviously, it all depends on the greenhouse gas scenarios. But, the current trend is like we are really not doing enough to mitigate the greenhouse gases to slow down the warming. And this 2-degree centigrade limit might not be achievable by 2050, as some wanted to. So when you look at the what happens in any kind of landscape, there are what we call compounding effects of threat multipliers. They could be sea level rise on the coastline, the big storms like hurricanes, maybe cyclones in our part of the world there. And in addition, we also have rising groundwater levels, particularly in coastal areas, because of the higher sea levels, urban flooding due to potential changes in rainfall patterns. So all these threat multipliers. So one research that we are conducting is what are the compounding effects of joint probabilities of these threat multipliers that we have to deal with. Many parts of the world, you already see effect of climate change. You see some figures of flooding up above in Florida. Places like Miami Beach, twice a day in this time of the year, streets are flooded, what we call sunny day flooding. And the middle graphic showing in Key West, there's a neighborhood that's flooded for 60 days continuously just from tide. So obviously, sea level is rising and having a significant effect on neighborhoods. But on the other extreme, we also have major droughts. The Western US is having, unprecedented drought, very low water levels in reservoirs, having major implications for water supply for agriculture and other. And hurricanes that come through, you never see very often New York subway being flooded from flooding due to storm surge, for example. Right now, there's the hurricane that came over from the West Coast in Florida had storm surges of 10 to 15 feet, in flooding some of the streets and have implications for infrastructure and others. Flooding is a major concern. This picture is for the flooding from the Houston. The streets were flooded for days, and then more recently in Pakistan and others. So basically, we are not having the same kind of climate we used to have. So we need to think about that when we plan the, engineering projects in the future. The occurrence of extreme storm, I just want to point out, this was taken, this category 4 storm coming on shore in Florida, not too long ago. It's still going through the state. Major storm event, and these things are happening more and more frequently, and there's expected to be a stronger and more frequent in the future, particularly the major storms under climate change. And when you look at the cost of these events, what we call billion-dollar disasters, they're increasing significantly in the recent years. This is might be the result of development, without any planning, and that is a sign that we are going to have more and more losses in the future. And one aspect of what we should think about, and which is not really happening in Sri Lanka in my mind, is this whole idea of floodplain management. If you take major river basins in Sri Lanka, every year one of the basins will be flooded now more and more frequently. But I think we need to think about floodplain management in the context of climate change, and it's something I've been trying to promote, in Sri Lanka for some time. The other aspect we don't talk much about as civil engineers is this groundwater or saltwater intrusion effect. Particularly along the coastline, we have this situation. The saltwater intrusion will basically affect, high-rise buildings or other buildings, and this salty water coming in and affecting the foundations and maybe even piles, that you construct for buildings and others. So this is a new area of research and I will tell you the reason why. So this video I'm going to show, it's from YouTube. Let me see. This is a collapse of a building in Miami Beach. And you will see that this whole building has collapsed. So this is what happened after the building collapsed. So everybody was wondering, we don't build engineering buildings or design buildings to collapse like this. So what is happening underground is probably the main culprit. The saltwater intrusion due to sea level rise basically corroded the foundation, and since something that might be sort of like a thread underground that we don't know about, and that's something we need to think about. So this whole concept of stationarity and non-stationality is something Professor Fernando mentioned, is something that I've been doing research on lately. Traditionally in engineering practices, we assume stationarity. That means it doesn't mean that it's not constant, but the basic laws and patterns will be the same. The past climate is an indication. So when we design for the future, we assume this probability of extremes will remain the same through time. And the idea is the key to the future. And we use the concept of return period that many of you engineers might be very familiar with. Now, under non-stationarity, the probability distribution basically will be changing with time. It will be basically lifting up with time because of this trend that we might experience in the future. So there are many challenges in analyzing this. We have done some research on how to plan for projects under future conditions like this, and basically in this case the past is not a good indication or best indicator of the future. We need to think about what could happen in the future. Can we extend this trend into the future? Those are some of the challenges. So we have a situation of dynamic return period, and I will explain that in a few minutes. But in other words, the return period as a fixed quantity cannot be used for planning anymore in this paradigm. And this is an example of sea level rise. Again, when or even in designing bridges or roadway infrastructure, the dynamically changing extreme probabilities will require you to have a new paradigm for planning and design. So this graphic, I don't want to go through all the details of that. The return period will actually decrease. If you design for 100-year return period today, for example, it will have maybe a 50-year return level or return period, by 2040. So in other words, your level of protection is decreasing. And same with another location. This is for the sea level rise on the west and flooding on the right. So in other words, the return period concept that we have been using as engineers for generations will not work anymore in this kind of setting. So we've done research. I'm not going to go to all the math on this, but we have redefined the return period as what we call expected waiting time. And we have come up with other definitions of how do we plan for changing frequency of flooding in the future, and came up with this return period concept where we can determine what do we need to design for today in order to deal with these changing conditions in the future. And this And also another concept that we are looking for, we have been using, is the risk-based concept. And this is the risk formula for non-stationarity. And one of the things that I have, this was developed for the National Climate Assessment in the United States. So under stationarity, with your design life, your risk is going to increase. That is natural under stationarity. But under non-stationarity, you're going to have a higher risk even for the same design life. I have come up with ways of, if you specify, I don't want to have a higher risk than, let's say, 50%, what you need to design for. So this risk-based design is an approach that could be expanded to vulnerability can be incorporated into this concept. So one thing we have done is to come up with this concept of adaptation portfolio. So what are the things that we could do in the future? And I'm not going to go through each one of those. So that is something that we have developed for the state of, for the South Florida area. What are the options we can use? Again, keeping in mind this concept of non-stationarity. So the concept that I want to promote is this called dynamic adaptive pathways. We work with the Dutch on this. The whole idea is that we are in an existing situation with highly vulnerable conditions, and we have had that for generations. There's no change in that. We have aging infrastructure, but we have this current situation. But the future is non-stationary. And due to climate change, it is uncertain because prediction of climate change is not easy. And we have what we call a situation of deep uncertainty. So how do we plan for that kind of uncertain future? So the approach is basically looking at different adaptation pathways and looking at tipping points. And so this concept of dynamic adaptation or dynamically adaptive pathways is a wonderful technique that we should think about in dealing with non-stationarity and climate change in engineering. And one example, we looked at an area in Miami, for example. We looked at various options or portfolio of measures, pumps to seawalls and others. And eventually elevating the roadways and houses. So, but the idea here is like, how do we phase these solutions in? And we came up with this pathway concept, at what sea level rise magnitude we need to resort to another measure in this set. So this concept of dynamic adaptive pathway is something very useful. And finally, I want to leave with these 5 resilience principles. So compared to what we have been doing, working in engineering in the past, we need to have a systems approach. We can't just isolate one area, the environment and other aspect of a project, which you might already be doing. We also need to think about beyond design events, because I think we are going to have a higher or more stronger events in the future, and we need to look at those as well. Number 3 is we need to think about how do we design a project using this concept of remain functioning. Just because you fail once, maybe the project does not need to be abandoned. How do we make sure and they can be used or design the project in a way that they can be enhanced or rebuilt very easily, and improve the recovery capacity by also looking at social and financial capitals, working with the communities. And then basically, how do we remain resilient into the future by looking at this concept like non-stationarity? With this, I will stop here because I think we might be already coming to the end. But anyway, with that, I guess we'll take questions at a later time then. Professor Fernando?
So we'll go to the next speaker. The topic of our next speaker is National Defense Against Intentional Electromagnetic Interference. As engineers, we are enthusiastic to hear about emerging technologies or the development of existing technologies. If any technology is a threat to the civil society, we must decide on what defensive measures to be taken. So this is a good forum for us to hear about defensive measures against intentional electromagnetic interference. To stimulate your thoughts on this aspect, let me invite Professor Chandima Gomes, a distinguished professor of high voltage engineering from the University of the Witwatersrand, South Africa. Professor Gomes graduated with BSc Special in Physics from the University of Colombo and joined the same university as a lecturer. He completed the Doctor of Philosophy and thereafter carried out postdoctoral research on lightning protection and high voltage engineering at Uppsala University, Sweden. He joined the University Putra, Malaysia as a full professor of electrical engineering and held the head of the Center of Electromagnetics and Lightning Protection. Professor Gomes is a chartered engineer, professional and chartered physicist, and a fellow of the South African Institute of Electrical Engineers. He was a senior advisor to the National Lightning Safety Institution, USA, the chief advisor to African Centers for Lightning and Electromagnetics based in Uganda, and advisor to several other national lightning and electromagnetic research centers in India, Nepal, Bangladesh, etc. He was ranked among the top 2% of researchers in the world by Stanford University, USA, and a highly rated scientist by the National Research Foundation, South Africa. Professor Gomes has published over 315 international research publications, including journal papers, conference papers, and books. He has conducted many training programs on lightning and transient prediction technologies and several other topics on electrical safety to the engineers in various countries, including Sri Lanka. Let me invite Professor Gomes to deliver his speech. Professor Gomes, the floor is yours.
With that, we can have some idea about how, as a nation, we can move forward in making this scientific issue for the benefit of our economy as well, while we are defending the security of our defense and civil systems as well. And okay, we all know that lightning is a natural, unintentional electromagnetic source. Okay, so when lightning strikes, say 150 or even 500 meters away from a conducting line like communication or power systems, then there are induced voltages which can destroy equipment, components, electronics at our premises, maybe a house, maybe a factory, maybe an industrial entity. But this is unintentional electromagnetic source, and also it is natural. Now, on the other hand, we all have experienced these in the good old days, in the 90s, 80s, 90s, and so on, especially when we had the tube-type TV. When our mom or the wife is operating a blender, we get some disturbances in the television system. So likewise, when one electrical equipment, especially with rotating parts, is operated, it may interfere with another electrical system. This is unintentional and not natural. It is artificial electromagnetic interference. Now, we know that in most of the petrol sheds, as we call in Sri Lanka, or gasoline stations in USA, using a mobile phone is prohibited. Still, people are stupid enough to use it. I have seen in my own eyes. The reason is that there is a very slim chance, okay? You don't find much literature on quantitative analysis of the effect of operating a mobile phone in a petrol shed, but it can induce a voltage at some parts of the fuel path, especially the conducting parts, which may cause a micro arcing that can trigger fire. It has happened, although it is not confirmed that it is due to the microwave generated voltage relevant to these incidents. We suspect that it is due to mobile phones. And this is unintentional or sometimes ignorant artificial electromagnetic generation. Okay, now we are coming to the interesting point. Say that this is unintentional or the ignorance of the person who's using the mobile phone. Say this happens. Now imagine a terrorist who brings an EM emitter million times powerful than a mobile phone fixed in a double cap. Then he or she illuminates the fuel path. When I say fuel path, it is it may be the pump, or it may be a tube which carries fuel from one place to the other, or it may be the end of the pump which is putting petrol into a vehicle. And then this may be extremely hazardous, and it is very possible. Okay, so these are not abstract things. These are very possible. And to be honest, I wonder why it is so late. Anyway, this is where we start our story. Intentional electromagnetic interference, which is a solid reality in the modern world. Now, the modern society heavily depends on the information technology that we all know. Now, a majority of public services such as power, communication, and so many things are fully controlled by electronic means, even supermarkets. The disruption of the information technology which control the computerized systems may handicap the entire civil network, thus causing financial and service losses, health hazards, distorted and chaotic society, and even political and military instability. Now imagine that if the total power system in a country collapses for 3 hours. I don't know in Sri Lanka, but in many other countries, that may be the end of the existing government. And imagine that if the banking sector collapses for a day or 2 days, that may be the disaster for a country. Thus, the modern-day terrorists and criminals tend to adopt sophisticated technological warfare rather than the traditional destructive techniques such as explosives and firearms. And let me go back to the scenario I told you about the petrol shed. Now, imagine that this terrorist, or whatever the name you give to this person who do the sabotage, comes in a vehicle, park it close to the petrol shed, illuminate the whole system for 1 hour, maybe not 1 hour, just say 10 minutes. Because if he is there for 1 hour, then maybe some people will suspect. For 10 minutes, nothing happened. He couldn't trigger fire or an explosion. He can come again next day. Nothing happens. He can come again on the other day. So he can come for 10 days until he achieves his target. So this is the danger of the electromagnetic terrorism. And now we'll see what is IEMI, or intentional electromagnetic interference. A skilled person can generate and direct an intentional electromagnetic signal not only to a remote control system, but also to a wire control system, thus interfering with the controlling mechanism of the system. In the worst case, the intruder can take the control of the system. In addition to the undesired signal, may cause maloperation, operation standstill, or even total destruction of the equipment. Such misuse of electromagnetic energy to disrupt the civil society is now commonly termed electromagnetic terrorism or intentional electromagnetic interference. If I go to the textbook type definition of IEMI, they say that the intentional malicious generation of electromagnetic energy, introducing noise or signals into electrical and electronic systems, thus disrupting, confusing, or damaging these systems for terrorist or criminal purposes. So this is how we define it. But in the last few days, they added to the end of this sentence terrorist, criminal, or industrial sabotage purposes, because that part now plays a big role in this game. So an electromagnetic emission that may cause an incident field which exceeds 100 volts per meter, corresponding to a plane wave free space power density of 26.5 watts per meter squared, is treated as a high power environment where the exposed electrical equipment may encounter a range of issues from temporary signal losses to permanent hardware damage. Now we come to defining the strength of electromagnetic radiation that can make impact on the electrical systems. As a majority of today's audience is not electromagnetic engineers, I try my level best not to go into the technical side or theoretical side and give you the picture where the risk is and what type of opportunities we have with this risk. Now, say for an example, if you have a mobile EM transmitter, this is the scenario we can see. It can emit, say for an example, one can even bring an electromagnetic emitter in a briefcase, or if you need a large-scale emitter, you can mount it in a double cab or in a small Jeep or truck, and then illuminate the entire system. So you can illuminate the power lines, the communication or electrical lines coming into a house, equipment themselves, or any other commercial system. And then, so finally what happens is that this illumination will generate a voltage impulse in these systems, which will destroy permanently or temporarily the electrical systems. Even if it does not damage, it can malfunction. It can mislead electrical signals. Now the question is, who will be the electromagnetic weapon users? Terrorists. It's very simple. Anybody can expect. They typically aim towards enemy targets to obtain military and political gains. Public services to disrupt the normal civil life and make chaos among the people. This is very understandable, I think. Then criminals. They may use electromagnetic weapons for personal rivalries, inter-gang warfare, mafia-type attacks, etc. Robberies, attacking locks, security and alarm systems, communication systems, etc. Frauds, illegal interfering with computer systems for accessing financial statements, secret documents, passwords, etc. Actually, that part is more defined under cybersecurity these days. So in the good old days, we define them under electromagnetic warfare. Or industrial espionage, sabotaging rival companies, suppressing competitors, and so on. Imagine that in a factory, if a very urgent, important supply is stopped by interrupting one part of the supply chain, that will be tremendously affecting the business of that company. The careless and stubborn people, the person who simply forgets or refuses to turn off a cellular phone, a laptop, computer, a radio, or any signal emitting device at critical places becomes a potential terrorist, even if he does not realize that. So we have to educate the public that even a citizen, a normal, innocent citizen, can be a terrorist who kills hundreds of people due to the carelessness and stubbornness. So people don't think about it. Then maniacs. This is a very important point. What we have seen in the arson, in the fire incidents, that there is a very high number of cases in the world where people, ordinary people, due to momentary psychological imbalance, psychological instability, have set fire to places where they should not even think about doing it. Even some people have set fire to ships. So the people, highly educated, skillful people with good knowledge of electromagnetism, can disrupt, destroy, or even sabotage systems without any reason, without any particular reason, just because they are mentally unstable. So this is something that we have to focus at. Then there are numerous sabotaging devices which have been reported recently. A very simple and cheap device can be designed with a microwave oven, normal kitchen oven, magnetron. Okay, so this is the danger. If you are skillful enough, you can just dismantle an old microwave oven, develop your own antenna system and a little bit of a electronic circuitry, and you are ready with your electromagnetic weapon. Then a small foldable umbrella antenna would give the device a 30 decibel gain. Thus, it can generate a field of 500 to 1000 volts per meter at a 10-meter distance, 10 times higher than the definition of damaging electromagnetic radiation. A slightly more expensive generator like Titan Spectrum, you can get over the shelf if you go to a country like Ukraine or most of the former Soviet Union countries. Then many other extremely powerful impulse generators like 400,000 volts Russian radon, and there are several others, I have not named them, you can buy if you go through the proper channels. No one can say that it is untouchable. So this is the basic concept of such a generator. And now I will quickly go through some of the devices available at present or easy to be made. Just to save time, I'm not going to the details. Just you can read them. This is a bigger type one. You can access them through military channels. So this is a briefcase planted continuous wave generator. And nowadays, one of the other scenarios which we are really scared of is the way that a terrorist can use a communication antenna, which is used for very good useful purposes, can be used as an amplifier for a electromagnetic generator which generate malicious waveforms. This is something that we are still studying on. Then if you look at the pyramid, then we can see that your blender or most electrical equipment, nowadays they come with much better electromagnetic compatibility measures taken at the manufacturing stage compared to 10 years or 15 years back. Those are very many, but their effect is mostly momentarily and also not very much affecting our systems other than inconvenience. Then the RF jammers used by police, military, and so on. It is the next level. Then comes the ultra-wideband emitters, which can disrupt up to some extent. But when you go to narrow band and this high power electromagnetic emitters, they can cause much higher damage. Then at the top of the pyramid, you will find this so-called high power electromagnetic pulses, which are usually generated by exploding nuclear weapons at high altitudes so that you can illuminate a very large area at ground level. So this is, you will find the damage to the electronic circuitry due to a 500 volt telecom pulse as defined in IEC 610045. Then there are several recorded incidents and I'm running out of my time. Therefore, I just flashed this and just I wanted to make sure that you understand that this is not an abstract case. There are many incidences where we suspect that some damage has happened due to electromagnetic interference. The problem is, in the 90s, we got many of these incidents in the public domain. But lately, after about 2004, 2005, suddenly, the developed countries understood the risk of giving the information of that to the world, so that most of the incidents are now blanketed from the public domain access. This again, I will not go into the details because addressing this scenario is really difficult for a country like Sri Lanka. But this is a real threat. Nowadays, the HPEM or even the normal electromagnetic generators can be mounted in drones and fly over critical installations, destroying the electronics. This also I will skip because it is a little bit of technicality. Then these two slides also I will skip because it is little more on the types of electromagnetic coupling. This also let me quickly go, just skip. This also let me skip, sorry. Okay, now I'm coming to an important point. There are a number of ways terrorists may use these EM weapons to attack military and civil targets. As far as the military is concerned, the aviation is at a risk of being attacked by EM means. A landing aircraft would typically be at a height of 100 meters at 2-kilometer distance from the edge of the runway. You just consider Atmalan Airport. For an example, in the case of an airport with an adjacent road, free movement of vehicles may be well within the distance. Again, Ratmalan Airport, the electromagnetic fields that can be generated at such a distance by a radiator of reasonable size are in the order of few hundred thousands of volts per meter if the source is HPM and few thousand volts per meter if it is UWB, ultra wideband. In case the aircraft is not compatible enough to withstand an illumination of such radiation level, the internal electronic network may fibrillate, result in the collapse of the airport, and the consequences you may understand. In the present context, an even graver scenario is the illumination of vulnerable positions at ground level with HPM or UWB by a low-flying light enemy aircraft or drone. The threat was very much there during the civil war in Sri Lanka, but unfortunately at that time, the drone technology was not that much developed, and also the emitters were not as powerful as we have today. So now you understand the threat. Okay, such an aircraft or drone may carry a sizable radiator and kill many electronics without arousing much alarm in the neighborhood. An air mission that destroys security and alarm systems together with a synchronized ground mission may result in damage beyond repair. And don't forget that when it comes to these EM emitters, I'm repeating this, the attacker can attack multiple times without the victim having no idea of what's happening. Then the civil systems, when anti-lock braking systems were first introduced, problems arose in Germany on the Autobahn when brakes were applied when the autos passed a nearby radio transmitter. So again, without going through this, what I'm trying to tell you is that speeding vehicles can be stopped instantaneously with electromagnetic interference. It can be used for sabotage, and also it can be used by police for, useful, I may say, purposes to stop a criminal getting away from them. And banking systems can be affected. Water supply, electrical supply, communication supply can be affected. So there are so many things that I have to tell, but I have no time to go through. Again, I will skip this. And the biological effect, this is maybe the last slide. Not last one, before last. The effect of gigahertz range RF on living beings is available up to some extent in documented literature in public domain, but on the human effect, the information is not much there. With available literature, what we can say is that, can we use this EM radiation to repel undesired animal intrusion, like elephants, monkeys, rodents? But research is done in this regard up to some extent. Pest control, then animal herding and directing fish movements, dispersing violent mobs. I think I better not talk about it at this moment in detail, not the right time. Okay, safeguarding the nation from electromagnetic terrorism. This is the most important, second most important slide. Safeguarding the nation. A military academia combined research task force should be employed to investigate the vulnerability of vital electrical systems to an electromagnetic attack. Okay, this is the recommendations I can give you. Consequently, systems should be strengthened in order to withstand a possible desired electromagnetic illumination. In addition, detectors can be developed, improved, or improvised at national level and installed at vital places. A team should be appointed to investigate the probability of electromagnetic intrusion. The government should take necessary actions for that. And the private sector can be a part of this. They should know the susceptibility. It is more convenient and less expensive to take measures. The public should be educated to understand the ways they can be affected. They should also be aware that even a well-educated person may become an intentional electromagnetic terrorist. Roadmap for the KDU, last slide. We propose KDU in coordination with the Ministry of Defense to assign a task force to formulate a mechanism to develop R&D and industry related to IEMI and EMC in Sri Lanka. Please note that today I talk only about the risk. There are so many aspects of this: risk, safety measures, industrial and research development, business modeling, commercializing, and so on. We propose this task force to liaise with countries that are in the forefront of research. USA and Sweden are in the forefront. If you want any help in contacting the right people, please let us know. I will be very much happy to help you. It's not only R&D, reinventing the wheel, we even can plug and play or copy and paste the already developed technology into the country. Then we also propose the Sri Lanka Standard Institution becoming an O member at least at the IEC 77 that works on electromagnetic compatibility and participates especially at TC 77C. If we can be a P member, it is more than, it's wonderful. And once the technology is developed and familiarized, we can develop our business model. Sorry for rushing through this. I wanted to tell these things in a way that you are convinced this is the time for you to take the steps, necessary measures, and come forward. Otherwise, you will find that you are too late and you are at the mercy of other countries. And there is a huge business model in this. At another time, let's discuss about that. Thank you very much.
So we will move to a third topic. The third topic of our plenary session is Towards Net Zero, Decarbonizing the Construction Industry. Climate change is a key aspect of the broader picture of sustainability. To mitigate climate change, 17 Sustainable Development Goals have been established, and among them, carbon footprint and embedded energy can be considered as key governing factors that would directly affect construction industry. To review on the innovative low-carbon construction materials, now we will invite a pioneer of this field, Professor Priyan Mendis. Professor Mendes is no stranger to KDU, as he is an adjunct professor attached to the Department of Civil Engineering. Professor Mendes graduated with BSc Honours in Civil Engineering from University of Moratuwa and received his Doctor of Philosophy in Civil Engineering from Monash University, Australia. He is a well-respected academic, resides in Australia with a solid background of working as a structural engineer, designing several skyscrapers in the Melbourne city skyline. He worked as a consulting engineer before joining the university. Professor Mendis is the Deputy Director of the Australian Research Council Industry Transformation Research Hub, transformation of reclaimed waste resources to engineered materials and solutions for a circular economy, and the convener of the Australian Research Council Research Network for a Secure Australia. He holds memberships in the Australian Standard Committees as well as Fellow of Institution of Engineering Australia and honorary lifetime member in Concrete Institute of Australia and American Concrete Institute. Professor Mendes received awards for recognition of service to protective technology at the Safeguarding Australia Conference in 2006-2007 and Eureka Prize for the best science-based research in Safeguarding Australia in 2013. He has over 500 research publications in many reputed journals and conference papers and technical reports in the research areas of high strength and high performance concrete, tall buildings, wind and earthquake engineering, fire performance of tall buildings, explosion effects on buildings, bridges and sustainable materials. So let me welcome Professor Priyan Mendis to the forum.
Thank you. Thank you very much, Professor Kumari, Fernando, and also thank you very much, Dr. Tanuja Kulatunga, for liaising with me and inviting me to this forum. Actually, I'm honored to be there, and always KDU, whenever I am there, I try to come and give a talk as well. So thank you very much for this invitation to be there among the very highly qualified plenary speakers today. Also, I want to just to acknowledge Dr. Kamal Laksiri, the president, really honored that he's here, president of Institute of Engineers Sri Lanka as well. And again, that this is really because I know we are really a little bit behind on time, so I will not take too much time, but just to fit into this also, I've selected a topic which really, it is really a hot topic now at the net zero. We all talk about it, and taking a leading role in Australia, and also in Sri Lanka, which when I founded the Sri Lankan Green Building Council in 2009, I was thinking that what I can do to give. We had free education. We were there. I'm still very passionate about Sri Lanka and what I can do. So forming that council, I think I'm very proud that Engineer Dalugoda talking as a director as well. He will say a lot of things about the green side too. And also I'm very proud that, as an honorary chairman of the CSEC group in Sri Lanka, and also been involved with the Lotus Tower and few other number of projects in Sri Lanka from the beginning. So that's really, I have a very a large involvement with Sri Lanka, and to be honored to have KDU and then Professor Poshan as well. So thank you very much for all that, and thank you, Professor Kumari, again for the very kind introduction you gave. So I just go to the next slide. Also, I want to thank Tusita Ginigadhara, who is really a product of KDU and also was a lecturer and is a very active member of my group here, doing lots of work already, producing outputs. I will talk about his one or two slides of his work. But anyway, this is really well known that greenhouse gases are, now what has happened to the climate is well known. So we all know about it now. Some of the talks I gave in World Green Building Council sessions, I had some of these slides. Then actually we already know about the ocean, the ozone depletion, the greenhouse gases. Now it's been there for a long time. So I will not go into just to save time. But this is real, the carbon dioxide when we measure with sensors, when we measure ppm, it's really, we can see it is increasing. It's really, there's scientific evidence now. There's no one could challenge the climate change. No one could. It's true that when we start in that those days when you're talking about it, there were some people were saying, is it true? But now everyone is convinced. Now, the temperature rise is also being proven, and it's really nothing really unusual now that it's happening. So we need to do something. And that's where all these net zeros, all that happen. We had to think about the next generations, and even the present generation is under danger if we don't do anything. So that's why it's a very ambitious target, the net zero 2050. Australia has come up with a target of 43% reduction in emissions by 2030. And for example, like we are closing down, today there was an announcement, closing down one of the coal-fired plants 10 years ahead of the scheduled close. They're closing all that very quickly. And Australia's economy depends on some of these plants. But we have taken some very brave decisions here. And I'm proud as well as Sri Lanka also following some of those. This interesting book by Mark Lenus. If you happen to read that, again, some of that work he has done, he's saying 6 degrees. Let's not worry about 6 degrees. He's saying 6 degrees, once we reach 6 degrees, the humans may not even exist in so many years' time. So it's true that whether it's 6 degrees or 2 degrees, it doesn't matter. What he has warned so many years back is that we had to do something. So now that we are seeing some action as well happening. So it is real. And we know some of the getting closer to us in Sri Lanka, we know the droughts are there, and climate change has effects. Floods were there, the landslips, all that, and have been there. So this is really happening. It is real. And the Glasgow summit changed a lot of things. And now the last 6 months, especially, things have changed so much as well. Everyone now talking about this, working on decarbonization. So we have been there before. So some of us had a head start. It's really, so we are continuing our work in that. So it's really, the decarbonization is a key word, UN sustainability goals and all that, really complying with that. So construction side, because my focus today is more on the construction side, to how the construction industry could contribute. So the construction and demolition waste. These are Australian numbers. We talk about 44% of the total waste generation in Australia. I will not read too much because it's really just to save time. Now the word circular economy comes in a big way. And what is this on the left-hand side? We have the linear economy that we are used to. We extract the resources, we produce something, we consume them, and we just dispose them. But on the right-hand side is a circular economy. Now, everyone talks about circular economy. So what is the circular economy? We produce something, consume, and then we do some waste management, and then we get the raw materials for the construction industry. So that is really coming a circle. We call it the cradle to grave and grave back to cradle. Cradle means birth to death before in the linear economy. Now we are going birth to death, coming back to the birth. So this is really a simple definition. I will just because I'm skipping a number of slides just to save time. It's just the 3 principles: eliminate the waste generation and pollution, and then we get to the decarbonization. Circulate the materials, and then we call it design for reuse. I'll give some examples from closer to me, why we designed them so that it can be reused. In the construction, some of the construction, and they can eliminate use of natural resources. We try and reduce the using of natural resources. This is my center, which I've been leading for a while, introducing prefabrication here in Australia. Now, of course, to Sri Lanka also, I've given some talks on this. I'm trying to bring that technology, of course, in a big way to Sri Lanka as well. So what is that is happening? That is we can produce in the factory. A lot of things will be done in the factory, transported, and then brought to the site. When I started the center, it was all new, and we all did a lot of work trying to introduce this to the Australian industry. So and then we placed them. The advantage, again, I will not read. Advantage is once we have used them in so many years, the design life, all that, we can reuse it. We can put it somewhere else. We can really dismantle it, taken off, because normal construction, we are used to in situ, all that. We can't demolish. We need to demolish the whole building or a structure or infrastructure. These ones, we can dismantle, we can remove it and place it somewhere else. So I will not go through in detail. Today is not to talk about prefabrication. Some of our work is not that easy. This was built in 8 days. I was involved in that at the beginning. So these are the modules we were doing. And then one of the world's tallest, I think this is the world's tallest real modular building. We have it in Melbourne, 54 stories. And I had some, not the full involvement, but I had some involvement in that. So these are really some examples from our center partners. They do houses. This is all done in a factory, brought to the site. And you can see it's not just boxes or containers. It can have any shape, anything can be done with this modular. All of the McDonald's is done there. All the schools, the advantage is that schools, just before the holidays, 2-week, 3-week holidays, now when students go home, they don't see. When they come back, there's real new buildings for them, because during the break, all that are done in the shops and factories and brought to the site and place. So no disruptions to classes. Schools are good examples. Railway stations, the workers go on a Friday evening, Melbourne, and when they come back, the old station is there on Friday. When they come back on Monday, they got the new station, no disruptions. So these are all done there. So I'll skip a bit more. So this is one of the railway stations. One of our center partners did this work. Healthcare facilities, the police stations, again, the advantage is post-disasters, when there are disasters and so on. After that, we can put this modular, the construction. Now, I'll skip these ones. Anyway, coming back to, I'll be a bit of a blitz or a very quick presentation, just to save time and to really move on. I know we are very late. So the recycled materials, again, this is a circular economy. This is a summary slide. Concrete is the most consumed substance in the world. The waste materials, we need to do something and reduce the non-degradable waste materials in landfills. We are closing landfills, plastics and all that, we are taking them out. So my group is one of the most active in Australia doing this work. The construction waste, we talk about concretes, metals, the asphalts. Now the roads are being recycled, timber, the roofing, bricks, all that. We work on all sort of areas. This slide, a lot of writing there, sorry about that. Just read at the bottom. Concrete is the most consumed substance in the world. Same time, it pollutes a lot. So 1 ton of cement produces 1 ton of carbon dioxide. So why it's happening? This is the cement process. I will not go through that. You can read, you all know, you can read about the cement production. This is where the problem is. Why cement why concrete or cement is one of the biggest polluters in the world. 8% of the emissions in the world is produced by this. So it's a big. So we want to get to net zero. We have to attack the concrete. We have to work on the concrete. Now, why it's happening is in the cement production process, limestone. We take the limestone and heat it to 1,500 degrees, and we get the lime. Lime is then we get this what is called a clinker and produces a cement. So this one, again, the carbon dioxide, obviously the calcium carbonate, the carbon dioxide in the limestone is gone to the atmosphere. So that's where the big problem in concrete happens. So because it's under heating, this happens. Then we get to what are the other things we can do for other materials. And I'll give some examples very quickly of our work on recycled materials today, and you can ask questions. And I'm there in December. I'll try to come to KDU definitely and give then you can ask questions as well. So in this case, the waste tire, the glass, we can recover. So the recovered glass, the waste tires is a big problem everywhere around the world. So we are trying to use these waste materials in positive way, not because in the construction materials, we just take a waste and then jump into concrete or something and say, right, we are using waste. we want to make use of the positive properties of those waste materials. Take rubber. It really increases the tensile strength. So we can put it to the roads. When you put it to the roads, we can get rid of some of the cracks, shrinkage cracks, temperature cracks like that. So we think positively like that. Waste materials, not just the waste material, it adds values to the construction materials. That way we are also reducing the emissions because reusing the materials. So some of the things like insulation properties can be increased by putting tire crumbs. This is a project that we are very proud of. Metro Tunnel is the biggest project in Australia at the moment. That's in Melbourne. So we are putting glass fines to concrete in that project. Not everywhere, but a couple of slabs in that as a trial. There's a big problem in the world is from lab to the real field. Lab, we can do many things, but really getting into the real field is the biggest problem. We were working also in Australia in this case, but what we're working on is also things like the pumps. When you put glass fines, the pumps get damaged. So these are practical problems. Lab, we don't see that. So these are the things, the real things that we had to do to get to the field. So there are a few things that have to be done. And to these are the glass we are using. Plastics, we are working with the biggest, the plastic, the recycling in Australia. We're converting them. This is factory. The Dr. Kasun Chanaka, product from Sri Lanka, is really leading this project, putting the plastics into various products. He's working on the artificial intelligence for waste identification and creating databases and training and all that. These are very sophisticated work being done. He's working on robots to really go and do the sorting rather than just people. So that sort of work being done with the industry. That is our strength, working closely with the industry, not just in the lab. So graphene concrete is a big one that our group is really working on. Tusita is leading that work, so graphene is the wonder material. Maybe today I won't have time to talk about it. There are increases of properties, compressive strength, tensile strength, flexural strength, abrasion resistance for roads. And that's really, we are the main research provider for this work. Working with, of course, the LOSC company with Mr. Shara, the group with Ceylon Graphene Technologies, where Wayne Graphite is we are very proud of this material because Sri Lanka is the only country you can get this purest type of the graphene, because there is high the Wayne Graphite in Sri Lanka we have. So now they have got a plant in Homagama. So really, rather than sending the raw materials, trying to send graphene oxides and on. So we are the main research provider. We are very proud. We could put with Mr. Shiromal Fernando, who is also adjunct in KDU, the CEO of the CSEC. We put it in the design office, the building. First time, what I call it, it was also helping this, but we put what is called a fruit salad slab, which really one of the first in the world to put all. This was done end of last year. We put everything into a slab this is in Madinagoda, the head office of CSEC. So we put all sort of things and it's into that. So it's been working in practice. So one thing, I will not go through this in detail, but embodied carbon, again, thank you Tusa for this slide. Embodied carbon on the y-axis, the concrete strength on the x-axis. So rather than just staying before the strengths, I will not explain everything. We are doing lots of calculations. Carbon footprint calculation is a key for any project. It doesn't matter with the civil engineering or any project, to get these numbers, the carbon footprint numbers, because we want to work towards net zero, we need to quantify. So in this case, we are quantifying, we are showing that by putting graphene, we can have the 32 MPa Portland cement concrete has a carbon footprint somewhere there. And then if you get to the 40 MPa with graphene concrete, strength increases, but the carbon footprint is same or less. Like that, it's another parameter has been added to our, not just the cost. So this will be seen in the next so many years in the world towards 2050 and beyond, of course, obviously. So this sort of quantification. So those who are working on we'll get to that and then try to quantify. We have a project where solar panels being recycled. We had to combine with the renewable energy. Mr. Dalugoda will be talking a lot about some of those aspects on the as well. So we are recycling one of the first recycling plants in the world, the solar panels. So we are working on that. I think we showed this one before. One last slide before I finish. I can talk for hours and hours rather than because we are like now I want to do it very quickly. This talk. I'm sure if there could be questions on this. So this is a new thing we have done is to use paper. There's a lot of paper being used. So why don't we try paper? This was sponsored by one of the Metro Tunnel project. This research work, we are putting paper into concrete and trying to put that in the real. We can do a lot of things in the lab, but in the real projects, that's where the gap is in the world. And this is the type of paper we are seeing, magazine paper to many other newspaper, all that, working with that the paper industry people, and then trying to put that into concrete has been successful. The initial work has been successful. One last one to say, textile is another biggest one, and some of that I think those probably got these textiles from somewhere there in is it Hamidias or something? Brandix, from Brandix. Thank you. This is with me here. Actually, helped with me. So he he did this work with Brandix and continued the work in Melbourne as well with the textiles, with the waste in concrete and the tensile flexural properties. So actually, the textiles increases the tensile strength, as you see here. It's not just a waste material. So use the positive properties of the waste materials. And that way, I think we can make an impact to the environment in the world. So I was only giving a few examples where from circular economy examples where modular construction, where you can dismantle and relocate somewhere rather than destroying. So connections and all that are very versatile connections where it can be removed at any time. So done in the factory, so quality, everything improves. Second example in circular economy in our construction industry I gave is using waste materials, which we'll see a lot because we are running out of construction materials. We are running out of sand. We are running out of lots of construction materials. Construction is increasing in the world in such a big way. And I heard Professor Obeysekara talk about the Miami, which I know I'm actually, in fact, some involvement there as a corresponding member as well for that investigation. But so it's a kind of thing that we should avoid, and I think we need to really work on avoiding those failures. Same time by thinking about the environment and using some of these newer materials. So we're careful to do that. So I'll just stop there. Thank you very much, Professor Kumari.
Thank you, Professor Mendis. And we quickly move to the final topic. The final topic of today's IRC Engineering Plenary session is Achieving Sustainability in Buildings. Now, we will look at the concept of sustainability from a different perspective. Buildings being one of the major energy consumers and greenhouse gas emitters, building performance directly affects the climate change. As a solution to this issue, the concept of green buildings has become a trend that is slowly catching up in Sri Lanka, with several LEED certified buildings coming up during the last decade. The director of the Green Building Council Sri Lanka, Engineer Chandana N Dalugoda, will discuss this aspect in detail. Engineer Dalugoda received the graduateship in mechanical engineering, specializing in HVAC and refrigeration technologies from City and Guilds of London Institute, UK. He qualified as a chartered engineer, worked as a manager engineering, and then promoted to chief engineer at John Keel's Holdings. After that, he joined as a senior mechanical designs engineer in HVAC at Moran, UK. He is a visiting lecturer at University of Moratuwa, Sri Lanka Institute of Advanced Technological Education, and ISL College of Engineering. Engineer Chandana is an ASHRAE Fellow, member of CIBSC, Fellow of Institution of Engineers, and member of Consulting Engineers Association of Sri Lanka. He is a recipient of 2015 ASHRAE Chapter Service Award and 2015 ASHRAE Regional Award of Merit. Let me invite Engineer Dalugoda to the stage.
Thank you very much, Professor. Well, I have to start now and I'll have to end now because my time is gone, is it? Anyway, we are going to walk through sustainable buildings. In brief, how to make a building sustainable. Well, sustainability. We are talking about sustainability. What is it? In quick terms. ASHRAE defines, ASHRAE is American Society of Heating, Refrigerating and Air Conditioning Engineers. They are the world's largest engineering institution, having 55,000 members in the world, in 190 countries. They provide all the standards for HVAC and R. So what ASHRAE says, providing needs for the present without detracting from the ability to fulfill the needs of the future. So stop waste, save for future is the simple terms. Most of the buildings are the culprits of carbon emissions. Now I suddenly saw this building, I don't know whether you have purposely made it, but absolutely right, the orientation. Isn't it? This is south, this is north, west and east, the other side. So there are no solar gain on these glasses. It is almost minimized. So wonderful. So reducing carbon footprint of buildings is a very pragmatic way to achieve sustainability. We'll see, quickly go through these. Carbon emissions are twofold. One is operational carbon and embodied carbon. Now, embodied carbon, Professor Priyan already discussed. The operational carbon is what the energy we use, we call in terms of carbon emissions. So what we are going to do, reduce this operational carbon emissions as much as possible. What we do for that is to stop and reduce, not stop, reduce heat gains. If it is a country like Sri Lanka, it is heat gains. Other countries, colder countries, heat loss. So we'll have to reduce heat gains of the buildings. For instance, the latest innovations are AAC blocks, aerated autoclaved concrete, highly thermal resistance rather than using brick or blocks. Using high performance glasses against just 6-9 millimeter normal glasses. Why not you use low E glasses, double pane? Costly though, but long term, it is much effective. Use of cool roofs. That means roofs should be heat. Now, I just can't imagine. We have zinc alum sheets, red color, green color, blue color. Instead, they should have had white color to emit more heat. So cool roofs, you paint roofs in white color to increase reflectance. And the thermal insulation for roofs, we don't do that at all in Sri Lanka. Then comes the equipment that you use in a building, how to reduce energy consumption. Now there again, we go back to ASHRAE. ASHRAE, so many standards are there, like ASHRAE 90.1 for energy efficiency. Whenever you select equipment, you comply with the minimum energy efficiency standards. Lighting power densities. Now, for instance, in front of Professor Lucas, I can't talk about lights, but lighting power densities, I think in Sri Lanka, for offices, it is in the range of 1.5 watts per square meter, like that. 1.5 watts. But this ASHRAE says you go down to 0.82. That kind of thing. Then building energy performance simulations. Now what ASHRAE suggests is to do a simulation, they guide and they tell you what kind of a equipment that you use and create a building and find that is called baseline building energy. And you are supposed to reduce minimum 10% from that baseline building. So that is green building actually. And finally, achieve substantial carbon footprint. So I'm not going to go through all these things. How ASHRAE standards we use in actual world. All the countries in the world has given a climate zone, right? If we select that climate zone, now in Sri Lanka, for that instance, zone 0A, that is extremely hot and humid. ASHRAE standard 90.1 has 0A table that gives you the values of thermal transmitters, for instance, thermal transmitters of walls, the minimum U value. The glass fenestration, U values, solar heat gain coefficients. If you achieve those things, automatically your building carbon footprint comes down. That's it. Now, for instance, this example, the U value of a roof, the first one, U value of a roof, this is concrete slab. 0.221 watt per square meter Kelvin, you got to achieve. Usually it is in the 1, maybe 2. So you got to achieve that to conserve energy. Fortunately, walls, we are within limits for Sri Lankan standards. Anyway, going back, I will just give you a comparison. On to your left, what you see here, our local industry U values, that is heat transmitters values used. Say for instance, concrete slab 150 millimeter thick, 2.26 watt per meter Kelvin. 2.26 watts per every square meter will transfer. But ASHRAE says drop it down to 0.221. That is how we save energy. Going back to a tile roof, 1.18, 0.153. Zinc alum roofing, 50 millimeter, 0.83. No, it should be 0.23. That's how we approach sustainability in buildings. This is AAC, autoclaved concrete, and you can see the resistance values. Common brick resistance in, of course, IP units are 4. Concrete hollow blocks are 1. These are 10. Thermal conductivity you can see. Then comes to fenestration, that is glasses. Normal glass, 6 millimeter, 6 watts per square meter transfers. Now, for sustainability, we'll have to drop it down to 1.73. Can you see? 1.73. So you got to do that. You'll have to, as a design engineer, you'll have to get that. Maybe laminated glass, a low E glass. Approach this value. So like that. Then the projections. Simple thing, everybody knows. But these consequences here for our advantage. Projection factor. You can see the projection factor, the width of the projection and the height. If you increase the width of the projection, your factor increases. The result is solar heat gain coefficient reduction. So I'm not going to go in detail, directly proportional. Okay, then the roof heat transfer. I will go through this since we don't have time. Otherwise, I can show you how we eliminate this thing. Waste, roof, 3 types. The concrete slab, then attic roof, and metal roofs. All require insulation. But unfortunately, Sri Lankan terms, zinc alum means God has given the thickness of the insulation 50 millimeter. No, crazy. No, it is not that. Now here, if you can see here, you need, this is, even before I touch this goes, you can see thickness, zinc alum. This is for a concrete slab. You need 3 inches plus 5 inches insulation, 8 inches. What we use 2 inches. Then another thing called continuous barrier. We don't have in our construction industry, other places. You have a continuous barrier, polythene barrier, that will prevent infiltration. Yeah, that gives a huge prevention of waste. Then, how to select equipment? All the equipment involved with a building will have to select with efficiency labels. Then, the building management systems, everywhere we use. What purpose? People are looking at a monitor. Isn't it? Mostly they might say, look, chiller is working, the fan is working, the lights are on, that's it. But they forget to implement energy saving strategies. These are the energy saving strategies. Come on. I'm looking at something. Energy saving strategies like chill water reset. Every large building chiller, during part load, if you increase 1 degree C, you get rebate 1.5% of the compressor capacity. It's huge. Then optimum start and stop. You don't believe buildings, I didn't include here. You start by 8 o'clock and stop by 5, this building, entirely central air conditioned. We can show, instead of you start 8, your systems, people come by 8. But what we do, we start by 7. All the chillers run at 7. Non-occupied. Yeah, but you would see, within course of the week, the thermal storage effect will have lower power consumption. And at the end of the week, 30% saving. I will give you an example, Ceylon Towers. Ceylon Towers. Carbon footprint saving is 30% by doing that with a magnetic bearing chiller. Electrical demand limiting. Now, demand limiting, your peak demand, say 500 kVA. That's set to the BMS. When the kVA approaching 500, automatically sends the signal to DDCs and the temperature of air handling units lifted up. That is 24 degrees C thermostat. Now it is going to 25. All the chillers are unloading, vice versa. So that kind of a thing, fan cycling, duty cycling, those are the BMS. So when you select equipment, this ASHRAE 90.1 guide you to give minimum efficiencies. Now, this one, what you see here, lighting power density is what I told you before. Lighting power density is, see, offices, 0.82. How to do it? Actually, we'll have to humbly ask Professor Lucas. He will tell you what kind of fittings that you use. You see, we'll have to get advice from people like them. But eventually, we'll have to have this comply these power densities. So converting to green building, right? I will quickly go. Now, green building has performance targets like this. minimal consumption, minimal atmospheric emissions, minimal discharge harmful liquid effluents, minimal negative impact on ecosystems, maximum quality of indoor environment. Finally, these buildings have savings. Can you see? Energy, 30 to 50% energy savings. Carbon emissions, 35% saving. 40%. So KDU must have a couple of green buildings, wouldn't you think so? Green Building Council Sri Lanka have building certification systems, certified building, silver rated, gold rated, and platinum. So if you can certify building, surely your carbon footprint will reduce. I like to invite all of you, if you are students, please go back today, go home and find your carbon footprint of your house. How to do that? Take 12 years electricity bill. Take total units. That is the energy consumed, other energy you don't have, multiplied by emission factor. The combined emission factor is 5.8, 10 to the power 5, I can't remember it just here. That is the equivalent tons of carbon, say 2 tons, let's say 2 tons. So that is your carbon footprint. So why we should calculate that? Now, you take measures to reduce that. That is how carbon footprint reduction. That doesn't mean you switch off lights and try to stay. So this is the carbon emission factors, and Sri Lankan emission factor is 5.8, 10 to the power minus 4, multiplied by your total electrical kilowatt hour per annum. That gives you carbon footprint. Finally, I have an example. This is the last slide. A proof of a green building. This was built, I think, probably 10 years ago. Iceland Business Center, Colombo. Now that saves 35% energy reduction, 45% reduction on waterways, 30% reduction in carbon footprint. So that's how we go for sustainability in buildings. Thank you very much.
Thank you very much. Yeah. Engineer Dalugoda, you can come to the head table now. Thank you very much for all the 4 presenters. I think we had very interesting and informative presentations. Unfortunately, time is barring us. Now we can take up a few burning questions as we are a little behind the schedule. Those who are online, you can put it in the chat box and the others can directly raise the questions now. And do we have mics ready? Yes.
Thank you, sir. All the 3 speakers from civil engineering background, the professors, thank you for your wonderful presentations. My question is especially towards, because all 3 of you were talking about climate change and global warming and also sustainable engineering. In this case, my question goes out to all 3 of you. We see that when we do things to the natural environment, there's a tendency that it backfires on us. So in this case, with the improvements in engineering, is there a way that we can actually use the natural phenomena to actually improve our engineering methods in the form of technology that can come with natural sciences to be used in engineering in the future? That's my first question towards the civil engineering professors. And also my second question is to Professor Gomes, which was regarding the EMPs, where I saw that he mentioned the possibility of a EMP used in an aircraft, and an attack can be done in a particular high security zone. In this case, as I have read about EMPs, it's very difficult to actually like seal off the electronics from EMPs or EMIs. So in this case, is it possible to use a EMP in an aircraft which has to be very much sealed to be flown while operating a EMP? These are my two questions. Thank you.
Okay, thank you. First question, who take it up? Prof. Obeysekara or Prof. We can't hear you actually.
I don't know what happened.
Now all right, yes. Yeah.
You can hear me now, right?
Now it's all right, yes, please.
Yeah. Yeah, I think the person asked a very good question, particularly the first question. I think I'll give you a couple of examples, but before that, in my presentation, in my 5 resiliency principles slide, I mentioned you should have a systems point of view, not just the civil engineering or civil infrastructure part you're looking at. You're having a complete systems view, which may include the societal interaction and the environment itself and water quality and all the other aspects of the whole system itself. And that would help you to think about some natural solutions that might help achieve your objectives. At least from a water point of view, I'll give you a couple of examples. One is when you try to protect the infrastructure from, let's say extreme events like storm surges, we use what we call natural and nature-based solutions. Basically on the coastline, this is why during the tsunami, the mangroves are thought to be very important. They help mitigate the energy coming in from storm surges and protecting interior infrastructure. So I think the natural and nature-based solutions, in the case of water resources systems, preventing extremes from doing a lot of damage, that's a very good example of using natural solutions to engineering problem. The other one is in terms of water use or water supply in civil engineering, water conservation is a societal change that we should encourage and educate the public of, particularly with respect to water quantity and maybe even water quality. I saw some pictures yesterday in that fire, and I looked at some of the water coming out of these environments. It's probably highly polluted. So that kind of public education and leading to improved water quality and water conservation. I mean, the cheapest water you can have is the water you don't use through water conservation. And finally, the long-term solution is like what we heard in others, excellent speeches today. How do you reduce your greenhouse gas footprint? Leading to long-term, mitigation of greenhouse gases, in our country and elsewhere.
Yeah. Okay. Thank you. Can we move to the second question, Professor Gomes?
Okay. Thank you. Thank you for the question. Actually, here we are not talking about isotropic emitters, or in this particular case, or NEMPs, nuclear electromagnetic pulses. Actually, here, in the case of drone-mounted or light aircraft-mounted emitters, we are talking about the high-power electromagnetic pulses generated by a magnetron, so that they can be directed away from the airborne platform, and also we can prevent any back intrusion or back radiation by properly designing the antenna system. So we have done this. I mean, we have seen that we can operate a drone, a very simple, commercially available, cheap drone with quite a significantly large emitter mounted without having any detectable interference with the drone electronics. Even the cameras were not affected. Hope that I gave you the answer.
Yeah, I hope you are satisfied with the answer, right? Okay. Yes. Just one more question. Yes. Yeah, please.
Okay, this question goes to Engineer Dalugoda. Thank you very much for most application-oriented and practical presentation. My question is, now we have had our own traditional way of like building the fabrication of buildings. So now what we use is what we have imported the technology, even the concrete from the West. So now you talked of the ASHRAE standards also. So how do you assess our traditional way of making buildings as per these ASHRAE standards?
Yes.
Absolutely nice, that question, because I myself suggested ASHRAE. We in Sri Lanka have clay buildings, our old one, and I gave them a lot of details, and there were so many research has been done in Sri Lanka. Even the last question that you asked, the answer is passive technology, passive. So here we should go for these things, but strengthening. We'll have to get Professor Priyan, Mendis, like that kind of their help and re-engineered. Definitely. Coming back, I will just give Dr. Kamal, if you. The previous one, passive technology, we'll have to use, for instance, now this place. See, why we air condition this? For comfort. For comfort. But comfort is another subject we have no time to discuss. But then, we are wrong. We all are in British attire. Okay? Like autumn in England. But I'm doing this comfort lecture at the university also. The most comfortable people I have ever seen in this part of the world is from Chennai. I did a lecture at Chennai University. The professor, the dean, everybody came. Short sleeve shirts, cotton. The trouser is cotton. And especially, no shoes, sandals. If you can remove your shoes now, you will be comfortable and you will complain, this is cold, knock off. So if you are in that attire, you may stop all these things. So the passive ways of cooling can be incorporated. Thank you.
Yeah, I think regarding this local materials and applications, Professor Halvathura has done a lot of research from University of Moratuwa. Yes. I think we are behind the schedule, but still we can take one or two. Yes, please. Yeah.
This question goes to Professor Priyan. We are running out of water. Water is getting contaminated. Yes. In Sri Lankan context, we are having very rich culture and ancient method of water purification. Can't we adapt such system with novel technologies. Like engineer we were using in good olden days, Morunga and Vatakeya.
I think this is really, can you hear my answer?
Yes, please.
Can you hear
yes.
everyone?
Yeah, we can hear
Yes.
you.
Yeah, sure. Thank you very much. It's a very good question. I think we can talk for ages. But before I answer that question, I want to say for the first question, also a very good question that there are some new designs coming. A couple of terms I will not explain because of lack of time. Biophilic design is the one which is coming to us using the natural environment or that to really so the word biophilic, those students over here can look for the word biophilics design and also the biomimicry, which is really looking at the natural environment and nature and so on to learn to do things in our building, especially I'm talking about more construction industry here. But a very good question on the water purification. And because it's really something coming up, because we are running out of water, of course, we have big issues. So it is really naturally coming out to do things. And Professor Obeysekara also mentioned about the salination problems, even attacking the buildings and all that. So I think it's coming up. I will not explain. I'm happy to really even take an email and explain. We are doing some work on even the cleaning the water coming from these tunnels work, the construction, and re-cleaning and putting it back. And here, actually, grey water, we are using all the water from the toilets and all that to reuse it for, not the toilets in this, sorry, the other water, the work in the kitchens and all that to really, to have for plants and all that. So recycling. So recycling is a big area. And I think, as you mentioned, the cleaning using natural ways are brilliant. I think there is something is coming up. Actually, even the work being done, for example, using the natural materials, and also talk about natural materials, and also the natural methods of, I can use the neem, the word neem, which is kohomba. So that's sort of, I think there are, purification was done naturally from our materials that ancient times came up. Some of those things can really purify the water. So it is really coming up in a big way. There are, at the moment, the methods are all chemical-based, that we are also cleaning some water, all sort of things chemical-based. And the water purification, I have to say that the work that's been done in the graphene is also another area where they are using those materials to purify the water. But natural materials is obviously a good choice. That's a good question. So we'll see more and more. At the moment, chemical methods are used for water purification, but natural materials are coming up, and we need to do a bit more. Very good question.
Yeah, can I add to that real quickly? I think
please.
One area that I want to add to that last question, in ancient days, when we have our tanks, we actually use that technique. The tanks were designed by our forefathers in a way that they automatically purify water coming out of agricultural land. You see a little area of a wetland upstream of a tank. So I think those types of systems that we can still use today, in Florida, we use what we call constructed wetland to purify polluted water coming out of agricultural areas before they go into large-scale wetlands. So the problem we have is we are losing wetlands more and more every day due to development. So we need to have some sort of a policy where we maintain the role and the amount of natural purifiers like wetlands we have. I think that's a technique that could be very effective in using and use this concept of one water. I think Professor Mendes alluded to it, the recycling. The concept now is one water. Basically, it's like I was thinking of basically cycling water, just like circular economy should be circular water, because wastewater we use for example, in maybe watering lawns and gardens now. So that's kind of what I wanted to add. Thank you.
Okay, thank you, Professor Obeysekara. We can take one more last question as we are behind the schedule. Yes.
Thank you.
My question goes to Professor Gomes. So these days we witness large scale power transmission without wires, the wireless transmission. For example, New Zealand is trying this. So my question is, what is your judgment about the electromagnetic radiation coming out of these transmissions to the health and operational issues of the people and equipment nearby?
Okay, you're actually asking me to open a can of worms. Actually, this is something different from what I have discussed today. Actually, here we are interested in gigahertz range radiation and how they are going to affect the human beings, or rather systems and even human beings. But your question is more towards the 50 hertz radiation, if I'm correct, the radiation due to power lines. And if you look at the research done in this regard for the last 10, 15 years, as you said, in New Zealand, there was quite an intensive research. But we find that the results are very much mixed. In one research, one says that there is a connection between the 50 hertz radiation or 50 hertz electromagnetic fields, better not use the word radiation, has some connection with diseases like leukemia. And sometimes the same research team, after 2 years, publish papers saying that their previous results is not very, or rather not confirmable, or not be validated. So in this regard, actually, even we have done some research in this regard in my university. What we have found is that we are in a very difficult situation to conduct such research. One reason is the difficulty in getting medical information, because in countries like South Africa and even in Malaysia when I was there, getting patient information is an uphill task. So that if somebody is doing a research in this regard, I think a country like Sri Lanka is much better, because getting access to patient data in Sri Lanka is not that difficult, as far as I know. Please correct me if I'm wrong. So that finally my answer is that I'm sorry, I can't give you any definitive answer to say whether the 50 hertz electric and magnetic fields due to the power lines has any direct effect on the human health. We need some research, and rather than making journalist type or media type statements, we better do proper research and then come up with the right thing to say. Hope that I have given you an answer, although I'm sure that you're not satisfied.
Okay, thank you. This is a very controversial topic in Sri Lanka. I know several high tension lines we have rerouted on the yes.
Yes, of course. That's why I'm a little scared to give unknown territories. I mean, walking into unknown territories and making statements which are not very appropriate.
Okay, thank you very much. I will give you a chance to.
My question is directed to Professor Jayantha Obeysekara. Thank you very much, Professor Obeysekara, for that very valuable and interesting presentation. You highlighted the importance of doing designs considering the aspect of non-stationarity arising from climate change. And one of the things that are arising is more severe, more frequent hydrologic extremes. If you consider increasing flood peaks or more severe flood peaks, what is the implication of that on the aspect of dam safety and the adequacy of existing spillways? Because to keep increasing the capacity of spillways would be a very costly and a huge exercise. Are there some non-structural measures which can be adopted in this kind of context? That's my question to you. Thank you.
Thank you. Very important and interesting question. I don't know if I have a full answer, but let me try my answer. It is very true that we have these extremes, bigger extremes happening, I would argue more frequently recently. So the question is, what do we do with the existing infrastructure? And then the other question I addressed was more like, when you plan a future infrastructure, how we need to account for those rare extremes happening more frequently. And I gave you some approaches for that. But let's think about an existing infrastructure. You pointed out a very important solution, some sort of a non-structural in the case of dams. First of all, I think need to understand the vulnerability of such systems, the current systems we have now. For example, if we get bigger extreme rainfall in tributary watersheds upstream of these dams, what would happen to our infrastructure? So sort of like a vulnerability assessment. And for that, we may need to do some climate modeling to understand what are the potential probabilities of these rare extremes, what we call black swans. The problem is we have more and more number of black swans lately. I think, in a training, some lectures I gave at Peradin a few weeks ago, I talked about adjusting the intensity, duration, frequency curves of rainfall due to climate change by conducting some climate modeling exercises to understand what is that change we could expect and do some vulnerability assessment. Then if your system is vulnerable, perhaps we should prevent that excess water coming into big dams before they get there. And maybe there are some upstream solutions, maybe best management practices, maybe making sure upland natural storage is not eliminated. We are destroying paddy fields every day for development, and those provide some natural storages to prevent all that extremes coming down the river systems. And I think there are things that we need to do some urban, watershed studies to understand what are those mitigating, solutions that we could do in the tributary basin. And not only that, but downstream of our dams. For example, I don't know, for whatever reason, we don't look at downstream of dams in many parts of Sri Lanka because, here we need to make sure that the communities downstream are also not flooded, during those extremes. So I think we need to look at both upstream and downstream, how to prevent this flooding, for example, during these more rare extremes that I think we will have due to climate change impacts. But there's not much you can do. Like you said, retrofitting the infrastructure in those big reservoir systems is not easy. But this is why when we build those systems in the future, we need to think about adaptive strategy. How do we expand the capacity of those systems in the future if the climate change tells us that the extremes are going to be more bigger and more frequent? Thank you.
Okay, thank you very much, Professor Obeysekara. I think time is not permitting us to continue the discussion. It's very interesting 4 presentations we had today, but unfortunately we have to move to the next program. So let me conclude the session. Now, first of all, let me thank all the 4 presenters for the excellent presentations conducted. I am sure there are still whatever problems you have through the conference secretariat, still you may be able to post the question to the resource persons and get the answers. So let me thank again on behalf of the participants today for all the presenters. 3 presenters joined virtually and the presenter Dalugoda joining with us today. With that, let me conclude. Thank you very much. Yeah.
Ladies and gentlemen, on behalf of the Faculty of Engineering of General Sir John Kotelawala Defence University, it is with the deepest sense of commendation that I extend my deepest sense of accolade to all our scholars who are joining us today virtually and physically to this hybrid daily word plenary session. As a symbol of our felicitation to our scholars who joined us today, to present the token of appreciation to our speaker, may I now have the honor of inviting the Dean, Faculty of Engineering, Captain S.U. Dampage, to accompany our co-chair for the session, Engineer Dr. Kamal Laksiri, to present the token of appreciation to our speaker, Engineer Chandana N Dalugoda. Ladies and gentlemen, may we now witness the occasion of presenting the token of appreciation to our co-chairs, to be presented by the Dean, Faculty of Engineering, Captain S.U. Dampage, accompanied by Commodore M.C.P. Disanaika. The token of appreciation to be presented to our co-chair today, Engineer Dr. Kamal Laksiri, the President of the Institute of Engineers, Sri Lanka. Sir, please remain on stage. The next token of appreciation to be presented to our co-chair, Professor Kumari Fernando from the Department of Civil Engineering of Kotelawala Defence University, to be presented by the Dean, Faculty of Engineering, Captain S.U. Dampage, accompanied by Commodore M.C.P. Disanaika. Thank you, sir. From the autonomous vehicles to the ICBMs or the intercontinental ballistic missiles, the world is developing despite the hardships and the economic turmoils. Achieving sustainability through research and innovation. Ladies and gentlemen, thank you for joining us today for the plenary session of the 15th International Research Conference of General Sir John Kotelawala Defence University. And we would like to have our panelists at the fellowship later. And you may now witness the poster presentation session. Thank you.